The chip formation. Shown in this image is shown the chip for different type of chip formation. This is a workpiece. The chip angles. This is a material removal angle. The importance of the grid shape can be easily realized because it determines the grid geometry. Examples: rack and clearance angle. The grids don't have a definite geometry and the grid rack angle may vary from plus 45 to 60 or more. Grid with a favorable geometry can produce chip in shear mode. However, grids having large negative rack angle or rounded cutting edge don't form chips but may rub or make a groove blowing, leading to lateral flow of workpiece material. Effect of grinding velocity and rack angle on forces. This is a grinding forces, positive rack, negative rack. These signs is grinding velocity. A negative rack angle always lead to high cutting forces and the temperature is high. The difference is narrowed at high grinding velocity and the grinding force become virtually independent of the rack angle. The various stage of grinding grit depth of cut. This is the grinding grit depth cut, rubbing, ploughing, shearing. A small grit penetrations, only sliding of the grit occurs against the workpiece. In this zone, rise of force with increase of grit penetration is quite high. With further increase of the grit penetration, grit starts flowing, causing plastic flow of the material, also associated with high grinding force. With further increasing of penetrations, the grit start cutting and the rate of rise of force with increase of grit depth of cut is much less than what can be seen in the sliding and ploughing zone. Variation of critical depth of cut with grinding velocity. The instantaneous grit depth of cut. Groove formation by ploughing. Groove formation by shearing. These are the cutting velocity, critical grit depth. Grinding is a combination of rubbing, ploughing and cutting. Certain level of grit penetration into workpiece is required before chip formation can start. Magnitude of critical grit depth of cut required to initiate cutting become less with increase of grinding velocity. Determination of density of active grinds. The Baker, Marshall and Shaw method, the grinding wheels is rolled over a glass plate covered with layer of carbon black. Penclick and Orgis methods employs of thermocouple located at the surface of the workpiece. As each active grind passes, a thermocouple injection is formed between the wire and the workpiece and a pulse is obtained from the high temperatures developed that can be counted using an oscilloscope. Grisbrook method. The surface of grinding wheels viewed on a projection microscope and the number of cutting points passing a line on the projection screen is counted as the wheel is rotated given amount. Testing of grinding wheels. Strength of the bond passes sintered metallic carbide or diamond chisels over the wheel surface in such way that it tears a layer of grain form bond. The forces required to separate a layer of grains from the bond are taken a measure of strength of the bond.